The graph shown below represents the solution set for a system of inequalities. Which system of inequalities has the solution set represented in the graph? If we examine all four multiple choice options, notice they're essentially identical with the exception of the inequality signs. Before we begin, let's review important information with graphing. When we are graphing, it is important in our review here that information is in slope-intercept form. This is a formula on the formula sheet. And what slope-intercept form is, y equals mx plus b. Yes, we're working with inequalities, but it's still part of the formula of the y, the m, the x, and the b. So we know that the b is the y-intercept, which is the starting point, and the ordered pair 0, b. And we know that the m is the slope, and slope is also equal to the rise, how we move up or down, over the run, how we move right or left. Other important information here is this. We see that one line is dashed. And we know that dashed or dotted lines for inequalities are not equal, so that is either a less than or greater than symbol. And one of them is a solid line, which means or equal to, less than or equal to, or greater than or equal to. So we know we need one of each, one with the equal, one without. Examining the multiple choice options there, we can eliminate option A because it had two solid lines. One solid because of the equal up top, and also solid on the second one. Part B has one solid, one dashed. Part C has one solid, one dashed. And part D has two dashed. So we went from going with 4 multiple choice options to now down to 2. It's either B or C. If we examine this, we know that the y-intercept for one of the graphs is at the -4. Notice that the -4 is the one that is the solid line. So if we look at B and C and where that -4 is, the only one with the solid is the C option. But to properly graph these, what we would want to do is first take the first line here. The y is less than 0.25x plus 2. So here, to graph this, I start at the y-intercept, the ordered pair 0, 2. The slope, the m, is 0.25. We do not like to work with decimal slopes, but we know that 0.25 is the same thing as 1/4. Up 1 and right 4. We also know that a less than symbol is a dashed line, and we know that less than symbol is shaded below. Therefore, the one that matches this is this one here, that top line, the dashed or dotted one, and I shade everything below it, all this information over here. The solution of this one is anything in the orange shaded region, but not on the line because it's a dashed line. Now you may be asking yourself, why is there shaded orange outside of the gray area? We'll get to that momentarily. If I look at the next line here, the one that I'm going to do here in purple, y is greater than or equal to negative 0.5x minus 4. The y-intercept was the negative 4. The slope is negative 0.5. Again, bad to work with decimal slopes, so convert that to a fraction, negative 1/2. Since this one was negative, it's going to move down 1 and 2 to the right. Greater than or equal to is a solid line, and greater than or equal to is shaded above. So that was this one right here. This line right here. Again with arrows because the lines keep going. And to shade this one, shading everything above it. And my answer for this one is everything in the purple shaded region, including the line because it's a solid line. And the last part I do is I identify where the purple and orange overlap. That is my actual answer, which is why this was the only shaded region in the question. We only theoretically shade the one part. If it's helpful for you, you can shade both parts like I did and then clearly label that the dark shaded region is the solution. Another thing we can do is using Desmos here. Since they're both in slope-intercept form, we could have graphed this. And we could have done each one, but just to verify this, I'm just going to test C. So y is less than 0.25 x plus 2. And the second one is y is greater than or equal to negative 0.5x minus 4. And what we see here, again, the colors may not match, which is fine for what I did earlier, but we have the one shaded region, the other shaded region, and the overlapping shaded region, which is what was shown in the problem. Again, the answer is anything in this dark shaded region, including anything on the solid line, but not items in the dashed or dotted line.